Hello friends, National Science Day is celebrated in India every year on 28 February. This day is celebrated across India to mark the discovery of Raman effect, which was revealed on 28 February 1928 by Sir Chandrasekhara Venkata Raman. We celebrate this day by public speeches, lectures, science movies, science exhibitions, debates, quiz competitions, and many more activities. It is celebrated to spread a message about the importance of science used in the daily life of people. Chandrasekhara Venkata Raman was born in 7th November 1888 at Tiruchirappalli, which was a part of Madras Presidency under British India. His parents were Chandrasekhar Ramnathan Iyer and Parvati Ammal. His father was a teacher at a local high school and later on appointed as the faculty of physics at Mrs. A. V. Narasimha Rao College. Raman passed his matriculation at the age of 11 years. He also obtained the BA degree from the University of Madras, where he stood first and won the gold medal in physics and English. He earned his MA degree from the same university with highest distinction in 1907. He joined the Indian Finance Service in Calcutta as Assistant Accountant General at the age of 19. There he became acquainted with the Indian Association for the Cultivation of Science, IACS, the first research institute in India which allowed him to do independent research and where he made his major contributions in acoustics and optics. In 1917, he was appointed as the first Palit Professor of Physics at Rajabazar Science College under the University of Calcutta. During his voyage to Europe, Raman was inspired by the wonderful blue color of the Mediterranean Sea. Coming back to India, he started his research works on the phenomenon of scattering of light. He discovered that when light passes through a transparent material, some of the light which is deflected changes its wavelength. The discovery was known as the Raman effect. Now let us try to know about the principle of Raman effect and how it can be used in Raman spectroscopy to perform analysis on a given sample. Let us first understand the Raman effect. When a sample is exposed to monochromatic light in visible region, the sample absorbs light and a major portion of the light is transmitted through the sample. However, a minute portion of the light is scattered by the sample in all directions. One can observe the scattering at right angles to the incident beam. The incident light has a particular frequency. If the scattered light has the frequency same as the incident light, then the scattering is called Rayleigh scattering. However, it has been observed that about 1% of the total scattered intensity occurs at the frequency different from the incident frequency. This is called Raman scattering. Raman scattering can be thought as a two-photon process. The electrons have different vibrational levels. They are defined by specific energy difference. When an incident monochromatic light interacts with the electron absorbs energy and is emitted to the virtual energy state. The energy transferred is given by the formula E equal to h nu I, where nu I is the frequency of the incident light. The electron then falls back to an energy level by losing energy. If the energy lost is equal to the energy of the incident photon, then the electron falls back to its initial level and this process emits another photon. Since the energy lost is equivalent to the energy of the incident photon, the released photon has the same frequency as the incident photon. Since the frequency is same, Rayleigh scattering occurs. However, sometimes electrons, when losing energy from the virtual state, falls into a different level. In this case, the energy lost by the electron is different from the energy of the incident photon. As a result, the photon emitted by the electron has energy different than the incident photon. This is possible when the frequency of the emitted photon is different than the incident photon. This gives rise to Raman scattering. Depending upon the final energy of the electron and the final vibrational level of the electron, Raman scattering can be separated into Stokes lines and anti-Stokes lines in the Raman spectra. If the frequency of the scattered photon is less than the frequency of the incident photon, then Stokes lines are observed in the Raman spectrum. This happens when the electrons absorbs energy. Similarly, when the frequency of the emitted photon is greater than that of the incident photon, then anti-Stokes lines are observed. This means energy is released by the electron. The Raman spectra gives the molecular fingerprint and it is different for different molecules. By studying the spectra, one can identify the rotational levels and thus a particular molecule. This helps performing qualitative analysis. Similarly, the intensity of a particular Raman line helps one to determine the concentration of a molecule in the sample. In this manner, qualitative analysis can be performed. For this discovery in 1930, Sir C.V. Raman was honored with the Nobel Prize for the Raman effect. He was also honored with the Bharat Ratna Award in 1954. In 1933, he moved to Bangalore to become the first Indian director of the Indian Institute of Science. He founded the Indian Academy of Sciences in the same year. He established the Raman Research Institute in 1948, where he worked to his last days. Raman served this institute as the director and remained active there. At the end of October 1970, Raman had a cardiac arrest and collapsed in his laboratory. He was moved to the hospital. He, however, survived for a few days and died from natural causes on 21st November 1970 at the age of 82.